Hi, welcome to my channel. So in this video, we'll talk about trigonometry. We'll have our focus on the common questions that come at grade 12 exams in trigonometry following the Zambian syllabus. Now, the four most important questions that may come at exams, we have the first one where we're told to calculate the distance. Then sometimes we may be asked to find the angles that will be there, solving for the area. And of course, the last one, I don't know with you, but I used to hate this part where it says calculating for the shortest distance. So we have a number of formulas to use, of course, following the trig ratios, that is, those are trigonometric ratios. I'm sure when you are given the right angle triangle, you can use the SOHCAHTOA, that is sine, cosine, and tangent there. But in an event where you are given a non-right angle triangle, then you are told to calculate n of the four that we've discussed: the distance, the angles, the area, and also the shortest distance. What should you do? Well, we don't have a direct formula in calculating for all of that. Maybe just for the shortest distance, but even for the shortest distance, again, we don't have a standard formula. Why am I saying that? Well, that is because a formula will depend on what side you are calculating and on which angle you are calculating. So, for example, we have a number of formulas in sine, that is when you are calculating for the area, for the angle, and also for the side. But again, to see which dimensions you are going to take, how you're going to arrange your formula, it will depend on which side you are calculating. Let's take, for example, this triangle that you are seeing there. So this is a non-right angle triangle. For now, just ignore this part where this h, this shortest distance. We'll come to it later on. So let's just say this is blank, and then we have x, y, z. Now this x, y, z, let us assume that we are given all these sides. There are dimensions that are being given on these sides, and then you want to find the maybe let's say this angle here. So the first thing that you should do is to label the opposite sides of the angles with small letters. So like this one here, the angle opposite to this one is this line, the whole of this line there. So we can label this one as that is with a small letter x. Then we look at this angle y, then opposite side is this one, so we're going to label it as a small letter y. And then we look at z here, so the opposite this one, and then small letter z there. Now, what did I mean by saying you come up with a formula depending on what you want to calculate? So let's say I'm calculating, I want to find the angle here, and I'm given this side is given, and also this side is given. Because when you are given all the three sides and then you don't have any angle, it's very impossible for you to use the sine rule. So what is going to work better is cosine rule. Now cosine rule states that this is small, since we are looking for this angle there, so we start with this one. We square this side. We say x squared is equal to y squared plus a z squared rather plus y squared, or maybe you can just say, you can just put them following the alphabet there. So you can say x squared is equals to y squared plus z squared minus 2yz cosine x. So that would be the formula there. But that formula can change when you are calculating for the angle, which is z. So instead of starting with x squared, you're going to start with z squared is equal to x squared plus y squared minus 2xy cosine z. In a like manner, if you're calculating for this angle here, it will be again, that is y squared is equal to x squared plus z squared minus 2xz cosine y. So that's what I meant when I said the formula changes depending on which side you are calculating. So you can use that formula, especially if you're calculating, you want to find one of the angles, but you are given all the three sides. Now, in an event whereby you have been given some sides and also some angles inside, you can try to compare. And how to calculate that one, you can try to use, of course, what we call the sine rule. The sine rule just brings those ratios and their angles. So for example, we have these ratios such as x sine x of x over sine x is equal to y over sine y is equal to z over sine z. So these small letters are the ones that we were labeling there. We had these small letters. So let's say, for example, we have been given this angle. Yeah, this angle, and of course we also have this side there, and we also have another angle. So we look at the ratios where only one is going to be missing. So we only use basically we just use two groups, like this one and this one. But we can still use this one and that one there, or this one and that one, depending on which side. Where when we substitute, we're going to have only one unknown. For example, if we know what is on y, we know what is on sine y, we know what is on sine z. It doesn't matter if we don't know what is on distance z there, because we can usually do cross multiplication there and then come up with the answer. So now we can use this, especially looking at what we are given in the question, and also which one is going to be very simple for us to solve, and looking at the parts of the equation that will make us at least to have only one unknown value there. Now let us look at when we are told to find the area. Again, for the area, we don't have a standard formula, because there's at a point where we have to use an angle. So you look at the angle that you are given, and from there you can see the formula that you're going to come up with. So for example here, let's say we've been given the angle Z. This angle has been given. So what would be the area be? So the area of this triangle is going to be half xy sine z, half xy sine z. So that will be the area. Now let's say we are given this angle, which is x here. So if we are given x, we are given this angle, it means that the area of this triangle is going to be half yz, half yz sine x, half yz sine x. Similar manner, when we're given this angle here, it's going to be half xz sine y, half xz sine y. So the way these questions are given, that's the way you should also try to come up with the formulas. It is the same with shortest distance again. Yeah, let us come back to the one that we ignored, this one there. So shortest distance, you can either, when you make a line from x there going to yz, you notice that you're going to have two triangles there. So it's either you can find the shortest distance using this triangle or this triangle. Well, the standard is that we say that, actually we say the sine of that triangle, of that angle, because we don't know here, we cannot say this is 90 or what, we are not sure. So we use the one that we've been given. So it's either we can say the sine here, the sine then is equal to h over what we are given on this dimension. We cannot use this dimension because this one takes from here up to there, but we are only considering from this one. That's why we use this sign, then we say h over this side. If we wanted to use this triangle here, we are going to say sine z. Again, we cannot use this angle because this angle is in both ways, so you can just say sine z is equal to h over y there. Now, if you want to make h the subject of the formula, it's going to be h is equals to y sine z. H is equal to y sine z. If it is on this one, h is equals to h is equal to z sine y. H is equal to z sine y. So I'm going to tag a video on how we're going to solve one question by applying all what I've said here. So I hope you like this video. Don't forget to turn on the notification button so that you'll be alerted each time I drop a new video like this one. Otherwise, I hope it helped you in some way. Look out for the video that will be posted on how we can solve, how we can put this to use now. Until next time, bye bye.